It's 1940, the absolute darkest depth of World War II. Nazi bombers are blacking out the skies over Britain in a relentless nightly blitz. To survive, the Allies desperately need a secret weapon that can see through the pitch black darkness and heavy fog to track incoming enemy aircraft. To solve this, the British physicists did not just build a better telescope, they engineered a top secret vacuum tube called the cavity magnetron. But just a few years later, a brilliant self-taught engineer standing in a defense lab noticed a weird side effect of this radar tube, one that would completely change domestic life forever. How did a melted peanut butter chocolate bar inside a high-security defense lab completely revolutionize how humanity cooks its food? The answer involves a top-secret World War II radar originally designed to hunt Nazi bombers in the pitch black. When you hear the beep of your microwave, you probably don't think about World War II aerial combat. But the exact same invisible wave technology that stopped the blitz over London and tracked enemy submarines is currently sitting in your kitchen counter. Today, we are looking at the engineering of the microwave oven. How a weapon built to spot Nazi bombers became the ultimate kitchen shortcut. If you love learning the crazy, accidental history behind everyday objects, make sure to hit that subscribe button to join us for the rest of the series. During early World War II, standard radio waves were too long to detect small objects like airplanes or submarine periscopes with any precision. The military needed microwaves, radio waves that had incredibly short wavelengths, and hence the name, to bounce off enemy metal and map out a precise digital eye in the sky. It was so highly classified and valuable to the war effort that a sample was rushed to America in a padded wooden box to kickstart mass production. This tiny tube single-handedly turned the tide of the war by giving Allied planes high-power, short-wavelength radar. By 1945, an eccentric engineering genius named Percy Spencer was working at Raytheon, one of the primary defense contractors manufacturing these military magnetrons. One day, Spencer was standing next to an active powered-up radar array. He paused for a moment, reached into his pocket for a snack and realized something bizarre. His peanut butter chocolate bar had completely liquefied into a warm, gooey mess. An ordinary guy would have cursed and changed his pants. Spencer, possessing the mind of an elite defense engineer, realized he had just witnessed a massive thermodynamic anomaly. He wasn't near a fire or a heater. The radar tube was cooking him from across the room. Percy Spencer's next move was legendary. Did any of you know the very first thing deliberately cooked with microwaves was popcorn? To test his theory, Spencer did not use military equipment to look for planes anymore. He brought a bag of unpopped corn kernels next to a magnetron. Within seconds, the popcorn was exploding all over the multi-million-dollar military lab. Next, he fried an egg, which promptly exploded in his colleague's face. The engineering crossover was brilliant. Spencer realized that the short radio waves meant to bounce off metal airplanes were instead penetrating organic matter. But how does a radio wave cook food without any external heat source? The answer is a process called dielectric heating. Most foods are packed with water, fat, and sugar molecules. These molecules are naturally polar, meaning they have a positive charge on one end and a negative charge on the other, essentially acting like a microscopic compass needle. The cavity magnetron blasts these molecules with electromagnetic waves, alternating at a staggering 2.45 billion times per second. Every time the wave passes through, the water molecules violently flip back and forth to align with the rapidly changing electrical field. This microscopic tug of war creates intense friction between the molecules. Unlike a traditional oven, which relies on hot air to slowly bake food from outside in, the microwave forces the food to cook itself from inside out by exciting its own moisture content. We are about to see how the 750-pound military behemoth shrank down to fit into your kitchen. But first, drop a comment below. Do you think microwave would have been invented this quickly without the pressure of World War II? Let's see your guesses. Immediately after the World War ended, Raytheon patented Spencer's accidental discovery. In 1947, they rolled out the world's first commercial microwave, heavily branded as the radar range. But the early civilian transition was a logistical nightmare. The first radar range was a monstrous machine. It stood nearly 6 feet tall, weighed over 750 pounds, required its own plumbing system to water cool the massive military tube, and cost more than a luxury car. It was strictly confined to military ships, luxury trains, and high-end restaurants. It took another 2 decades of defense industry scaling to shrink the magnetron, replace the water cooling system with simple air fans, and drop the manufacturing costs enough to fit into a compact, affordable countertop box for everyday homes. By the 1970s and the 80s, the microwave oven had become a ubiquitous household staple, a piece of hardware born out of the desperate engineering race to defend the free world from aerial annihilation was completely domesticated. Without the massive blank check funding of World War II defense programs, the precision engineering required to mass-produce cavity magnetrons would have taken a century to develop commercially. Every time you hear that familiar beep and pull out a hot plate of leftovers, you're using the exact same electromagnetic pulse that once swept the English Channel for enemy warships. A tool designed to survive the battlefields of World War II, repurposed to make 3-minute popcorn. What's the next war tech turned civilian miracle you would want to see? Let us know. Don't forget to like and subscribe.